Let's have a look at the equation of continuity. We look at our equation sheet. This is it here. It's two parts. The volume flow in is equal to the volume flow out. Q1 is equal to Q2. Well, let's have a look at this one right here. Q1 equals A1 V1. Q1, this is known as the volume flow rate. Volume flow rate is equal to the cross-sectional area, 1, cross-sectional area, times the velocity of the fluid going through this particular pipe. We look at the units. Volume flow rate is equal to cross-sectional area in meters, will be meters squared, and velocity is meters per second. Therefore, the volume flow rate, when you multiply these together, is equal to cubic meters per second. And cubic meters is a volume over a time. And that's what volume flow rate means. Sometimes this is also written as Q dot. Q dot. Q dot means volume flow rate. And rate is a word, rate, here it is something divided by time. And here is something divided by time is a rate. In our case, it's a volume divided by time. And that's what this word problem here is meant to elaborate on. So let's have a look at this word problem. Keeping in mind continuity equation, this one. Water flows in a volume flow rate of 1.5 cubic meters per second in a pipe. Find the water speed where the pipe radius is 0.5 meters. Well, let's have a look at this number right here, 1.5 cubic meters per second. This is the volume flow rate. But who understands cubic meters per second? I don't know. Let's change this to something we all understand. Just for the sake of argument, let's have a look. So we're going to change this into liters per second. Remember, cubic meters is a volume. So change 1.5 cubic meters per second to something we all understand. Let's make that liters per second. We can change that to gallons per second, but we're going to go with liters per second, stay metric. Okay. To do this conversion, what we need is some conversion factors. 1 liter is equal to 1,000 milliliters. And 1,000 milliliters is also known as 1,000 cubic centimeters. Okay. Sometimes this is written as 1,000 cc, cubic centimeters, which is also 1,000 milliliters, which is equal to 1 liter. And we all know that 100 centimeters is equal to 1 meter. Knowing these conversion factors, actually these are equalities, we're going to convert this into liters per second. Write down the value that we want to convert. 1.5 cubic meters per second. The seconds we want to keep. We just want to change the cubic meters into liters. So let's change this into cubic centimeters. Cubic meters into cubic centimeters. 100 centimeters per 1 meter. We have to do this 3 times. That effectively changes cubic meters into cubic centimeters. All those come out. This would be cubic centimeters. And let's change this now to liters using this. And let's see, we'll follow the units. This is cubic centimeters on the top. We want to put cubic centimeters on the bottom. And this will be 1,000. 1,000 cubic centimeters to 1 liter. Cubic centimeters all cancel out, effectively giving us liters per second. After doing all the math, this comes to 1,500 liters per second. Now that's a lot of volume of water flowing through a pipe. So let's draw a picture of this pipe. it has a radius of 0.5 meter. So here's the pipe. Radius generally means that it's going to be a circular cross section. So this is the pipe right here. And it has a radius of 0.5 centimeter, or 0.5 meter, I should say. Therefore, the diameter is 1 meter. That is a very large pipe. Very large pipe. And the cross-sectional area will be this area right here. And for our equation to be valid here, this pipe needs to be filled with water. So the whole thing here is filled with water. And what this means right here, Q dot, the volume flow rate, is if I do a cross section of this pipe, looking at it sideways, water will be coming out of the pipe completely filled. And this will be the velocity of the water coming out. And Q rate means there'll be 1,500 liters of water gushing out of this pipe every second. Well, that's a big, big pipe. Again, for our equations here to work, for what we need to do, this has to be completely filled with water. Having said all of this, now let's put this to use to solve this problem. Water flows with a volume flow rate of 1.5 cubic meters per second in a pipe. Now we have an understanding how large a volume that is. And find the water speed. We want to find its velocity here, leaving the pipe. Draw a quick picture of what is given. So we know it's going to be a circular pipe. And it's going to be filled with water, completely filled. And we're given the radius is equal to 0.5 meters. Write down a little list of what is given. The volume flow rate, Q dot, is equal to 1.5 cubic meters per second. These are improper base units. Velocity is what we want to find. We don't know what that is. And the cross-sectional area, that is the area right here of the pipe, or this portion inside here, if you're looking sideways, or that portion there. That is the cross-sectional area of the pipe. And this is a circle, and the area of a circle is pi r squared, and we're given the radius. So we can easily put in the numbers. Pi times 0.5 meters, everything squared. And we'll call this A1. Call that Q1, V1. A1 is equal to pi times 0.5 squared, meter squared. Square on the 0.5 and square the meters. So it looks like this. Our equation of continuity, right here. Volume flow rate Q dot is equal to the cross-sectional area. In this case here, we're going to call cross-sectional area 1 times the velocity of that fluid, in this case being water, that is exiting the pipe. Putting in the numbers now, we know what the volume flow rate is, 1.5 cubic meters per second. We know what the area is, pi times 0.5 squared, meter squared, times the velocity is what we want to find. Multiplying both sides by the area, isolating velocity, it would look like this. 1.5 cubic meters per second, everything divided by this term. Pi times 0.5 squared, meter squared is equal to the velocity. Looking at the units, and I'll leave it for you to rearrange the units, but these two will cancel out, meter squared will cancel out, and there's 3 here, so 2 will cancel out, leaving meters to the power of 1. So what's left over is meters per second. And that's good because velocity has the units of meters per second. Doing the math, this comes to 1.909859, and the units is meters per second. Therefore, the velocity of, in this case it's water, the velocity of the water leaving the pipe at this point. Find the water speed. Find the water speed where the pipe radius is 0.5. And we're going to reduce this to two significant figures here, two significant figures there. To 1, 2. Look at that third one. It's a 0, so we're going to leave it at 1.9. It's approximately 1.9 meters per second.